Welcome to Gentech of Colorado, Edwards Air Force Base Generator Owners Training. The first place that we want to go is to EAFB Training.weebly.com. The password was changed to capital S, capital D, 100, lowercase training. This is your site where we can hold a lot of your documents. This site was created specifically for this training. This is where we can actually upload and make changes and find the documents that you need for not only this training but for continued training on this generator. Looking at your home page, this just goes into a little bit of our on-site customized training. We do offer a 3-day power generation seminar, offers valuable hands-on learning with a lot of functional equipment that complements classroom instruction. Feel free to contact me for more information on this, and I would be happy to provide that for you. I'm going to click on operating training here. This is a page that will have a lot of information. The information you're seeing on the screen will be changed and customized. So everything that we go over today can be found here for easy access. The main component that I first want to discuss is pulling up the actual submittal document. So you should be able to click here and download that file directly from this page. Here we can see our submittal package. This is going to have all the information on the equipment that was ordered, installation, etc. We always include the pre-startup checklist before we go out on site. So we're going to scroll down here to the bill of materials. This is essentially proposals showing the components that we sold as well as some of the configurable options that we have. So we're going through the bill of materials here. We're going to go in depth on the actual submittal documents. So prior to any training, the installation guide, the owner's manual, and the submittal docs will be uploaded onto your web page, the Weebly web page. And so prior to this training taking place, this needs to be distributed to all of the participants who are taking part in this training. Need to go through every page in this document. In these documents, you'll be able to download again from your customized website. And we want to have a list of questions, anything that comes up prior to training, so giving ample time for each participant to go through these documents, 2 to 3 hours. There's a lot of pages, a lot of information, and provide a list of questions you have prior to training. Ideally, as we go through this training, all of those questions will be answered. If there are any remaining questions, again, reach out to me. We can go over those and I can get those answered, submit that to my email, to my contact information, and we can go over those a little bit more in depth. But the idea of this is to provide sort of that basic owner's training that we normally do, as well as going into some of the more details of the unit and also just general overview of the equipment and the functions and how that works. So this is a pretty comprehensive training, but again, please contact me with any questions, concerns that you have, and we'll be sure to get that answered to make sure that you are completely comfortable with this unit and every question is answered moving forward. Okay, so here we go. So we're going to start with the H panel for our training, and keep in mind on the picture-in-picture of our service tech, Dylan, It's important to have proper safety, so that means we can't have any loose jewelry, we have to have gloves on, we have to have eye protection. Anytime that we're inspecting a generator, working on a generator, servicing a generator, we have to follow those guidelines. So first we're going to talk a little bit about the H panel and some of its functions. The H100 control panel, it's an electronic control box that functions as an advanced standby generator controller. It has a lot of flexibility. It has a familiar user interface in form of GenLink DCP, so you can monitor and change the parameters in the unit. There are specialized programs that are built into the H100 control panel that allow customers to configure spare I/O to their own needs. So basically, what is your H100 control panel? It's the brains of the operation. It's taking all of these inputs and it's putting it out for you, the customer, so it's easily read, easy to program. It basically takes everything that's happening and gives you that display, so you can configure it to your needs and understand what's going on with your generator set. That is really the function of the control. H100 control panel and the PM DCP products can call out for assistance via a modem. Every product can provide trending data for its measured parameters. Any measured value can be set up to create alarms or warnings. Each product has a built-in ILC, etc. H100 control panel overall is very flexible. So in terms of features, you have local and remote connection to a PC for GenLink DCP connection, interface with up to 2 remote annunciator panels. The display is very customizable. It does have a built-in frequency and voltage controller. You have communication via standard CAN bus and Modbus protocols. Like I mentioned before, the programmable I/O channel properties, programmable alarm and warnings, alarm and event logging with time stamping, parameter logging and trending, both to file and graphical. The H100 control panel controller is set up in the factory to match the product it is shipped with, and generally no changes are required. For spares purposes, the controller can be reconfigured in the field using the GenLink software tool and a PC. If you need to change the function of the panel, the best way to get a basic setup for a product is to use GenLink to download a product file. This will set up all the basic parameters and just leave customization and calibration to be done. Product files are available on the website for downloading, cross-reference to product serial numbers, generic product types. The manufacturer does not recommend changing the settings individually for a product, as this is laborious and prone to human error. Some of the settings require detailed knowledge of things like governor settings, which are not easily discernible. We can go kind of through this a little bit. I mentioned some of these standard features, and then some of these customizable features that we can work on. And we're going to go into this a little bit more. Really what we're looking at is things like the weekly exerciser. We want to be able to do remote communication, and we want to monitor all of these things. Another important one that we're going to go into is this fault history and alarm log. So sort of resetting with these basic alarms and moving on from there. So here is the front panel display. I have a picture-in-picture on the right that will also show this. The panel display consists of 2 LCD displays. There are 4 rows of 20 characters each, and a keypad with 7 buttons and 2 LEDs. So on this left side, this is a fixed set of parameter pages, and it has no cursor or entry fields. So the keypad has no direct control of its contents. It's predetermined by menu selection on the right display. So we can see an example of that right display there. There are several pages on here. It responds directly to the keypad. So there are 2 quick buttons on the keypad that are used to go directly to either the home page or the menu page. The enter button is used to enter and exit edit mode, operate in output override, or select another page. Now, when you're not in edit mode, the arrow buttons are used to navigate around the page to either an edit field or a control field. And when you're in edit mode, the up-down buttons slew up or down through the available values, and the right and left buttons are used to change to a different digit or to edit field. Now, if you're moving off an edit field when in edit mode, it automatically enters that value displayed. Also, while in edit mode, pressing the home button will return the parameter to the last value entered. So as we talked about, that left display has 5 fixed parameter pages. That's system voltages, system power, transfer switch mimic diagram, generator frequency graph, and system alarm log. Now, the left display page is determined by selecting the right display menu item, left display. To change the left display, do the following. Press menu, use your right arrow to move to the left display field, and then you want to press the enter button to display the left display menu page. Now, as you can see with these arrows, that's going to indicate which page is currently displayed on the left display. So use the arrow buttons to move the cursor to the desired page name and press the enter button. The left display will change to the new page and the arrows will move to the selected page name. Here's an example of your typical 3-phase system voltage page. Line 1, we're seeing 5 phase titles for the voltage and current. Line 2, line-to-line voltages in volts, RMS. Line 3, line currents in amps, RMS. Line 4, generator frequency in hertz and total system power in kilowatt. This is an example of the switch page. So we went over volts page really quickly. This is simply transfer switch mimic diagram page. It's going to show the position of the utility switch and the generator switch. There are options on here to select multiple ATSs to see that status. We won't need to go into that because we only have one switch. So on line 2, that's the title line showing the left side is the utility switch and the right side is the generator switch. Line 3, we're seeing character graphics showing the switch states open or closed. Line 4 is character graphics indicating the load coming off the bottom of the actual diagram. Now we're moving on to the alarm log. So this is an example of the system alarm log page. This is going to display the last 20 alarms or warnings that occurred with a time and date stamp. So we're seeing 2 records displayed at a time. Lines 1 to 3, the record's alarm or warning number. So that's the lowest number being the most recent, followed by the date and time that alarm or warning occurred. On line 2 to 4, the alarm or warning description message. The depicted display shows a basic format in place of the first record and an empty record for the second. The records scroll up at about a 4-second rate. And so the first 2 characters, here we see 2 question marks. That means it's an empty slot. A WR is warning. AL is non-shutdown alarm. SD, shutdown alarm. And then on those last 2 characters, we see an SN for sensor failure, HI for tripped by being greater than threshold, and LO, tripped by being less than threshold, and then blank, that's an internal alarm or warning. Moving on to power. So this is a typical system power page. Line 1, we're going to see the total system real power in kW, that's kilowatts. Line 2, total system reactive power in kVAR. Line 3, total system apparent power in kVA. Line 4, total system power factor. So we want to kind of go over what some of these terms mean. The best way to do it is typically showing a beer mug. And so to understand power factor, we need to understand a little bit of these terms. So kW is your working power. So it's also called actual power, active power, real power. It's the power that actually powers the equipment and performs useful work. kVAR is reactive power. It is the power that magnetic equipment, so your transformer, motor, relay, needs to produce the magnetizing flux. And kVA is a parent factor. So it's sort of a summation of kVAR and kW. So the example of beer makes sense. You're at the ballpark, it's really hot, so you want to order a beer. Now, the actual beer in here is the thirst quenching portion of your beer. That's kW. That's represented here in this photo. Life isn't perfect. We all know that, and so there's a little bit of foam on top. And foam isn't going to quench your thirst. It's not going to power anything. Foam is represented by kVAR, and then the total contents of your mug is kVA, is the summation of kW, so your beer, and your kVAR, which is the foam. So understanding these basic terms, power factor is the ratio of working power to apparent power. So power factor equals kW divided by kVA. So looking at your beer mug analogy here, power factor would be the ratio of beer, kW, to the beer plus foam. Now, if we're in a perfect world, your kVAR would be very small, kW and kVA would be almost equal. So that's more beer, less foam. In order to have an efficient system, whether it's beer mug or your generator, we want power factor to be as close as 1.0 as possible. Now, since power factor is defined as the ratio of kW to kVA, we see that lower power factor results when kW is small in relation to kVA. So what causes a large kVAR in a system? So that's inductive loads. Inductive loads, which are sources of reactive power, include transformers, induction motors, induction generators, high intensity discharge lighting. So they constitute a major portion of the power consumed in industrial complexes. We'll jump into that a little bit later. I don't want to get too in the weeds. Right now, we just want to know that we are as close to 1.0 power factor as possible, that that generator is running at its peak, and it is giving you the most amount of beer and the least amount of foam per our analogy here. Let's jump back to these right display pages. The right display is menu-based with 8 main menu items: system alarm and warning pages, engine parameter pages, system status pages, maintenance status pages, left display menu page, generator parameter pages, system diagnostic pages, and internal exercise and ATS page. To select a page for the right display, make sure that you are pressing menu and use the arrow keys to move the cursor to the desired menu item, then press enter. Most menu items have multiple pages under them. When that's the case, there is a more arrow button field at the lower right hand corner of the page, where X is the page number and Y is the total number of pages available under this menu item. To move forward and backward through the pages, the cursor is placed on the arrow keys, either one, using the arrow buttons, and the enter button is pressed. When a page is first displayed, the cursor normally starts on the first character to promote ease of scanning through these pages. So now we see a typical system alarm and warning page. We see an NA that indicates there's not an alarm or warning to display on that line. As depicted, this display indicates a fuel pressure alarm for low pressure. This would be a common alarm for a system that has the gas line turned off. The AL indicates it is in alarm, and then you can see that little star indicates the alarm has not been acknowledged. The D12 fuel press message indicates it is a fuel pressure alarm. D12 was indicated in the text by the user to indicate it is digital input 2. The low indicates the alarm was tripped because the input value fell below a set threshold. So press enter, the enter button while the cursor is on that ACK. That's to acknowledge the alarm. And what you'll see is that star is now gone since the alarm has been acknowledged. And in the example that we used, you could now turn on that gas alarm, and the alarm will have cleared since the gas pressure is now adequate. So that's one example that we would use to acknowledge a common alarm. So next, this is a typical display. If we click on engine, so this is the engine parameter page. A typical example, there are 3 values on this page, are not to be configured as other values. So line 1, this is oil temperature, that's in degrees Fahrenheit. Line 2 is oil pressure in pounds per square inch. We have line 3 displaying coolant temperature in degrees Fahrenheit, and then more field to allow page selection. So if any of these signals are not configured, they will display NA for their value, such as oil temperature shown above. So let's see what when we click on that more page. So this is a typical second engine parameter page. The first 2 values on this page are not able to be configured as other values, so we clearly can see the engine RPM. Line 2 will show that battery voltage. Again, if these signals are not configured, they will display NA for their value. Line 3, we're seeing normal battery charger current, and line 4, we have more again, and so we're going to click on that. So we're kind of getting an idea of how the H panel works, how we can navigate it. This is another important one. It's a third engine parameter page. Line 1, we're seeing total number of hours the engine has run. We're seeing the coolant level sensor. And then line 3, this is often the fuel level sensor. And then we have more. We can go through these as you have questions on them. I just wanted to give you a kind of a brief overview of how to navigate this. I don't want to bog you down too much with this, but we'll have a couple other items coming up, and then we'll move on to something else. So here's an example of a typical for system status page. Line 1, you can see engine running status. It can have the following values: stopped, comma, key, SW off. So that means the engine is stopped and the key switch is in the off position. Running from manual, the engine is starting or running and the key switch is in the manual position. Running from 2-wire. So the engine is starting or running because the 2-wire start signal was activated and the key switch is in the auto position. Running from serial, the engine is starting or running because the Genlink commanded it to start and the key switch is in the auto position. There's running exercise. The engine is starting or running because internal exercise was activated and the key switch is in the auto position. We can see stopped key SW auto. The engine is stopped and the key switch is in the auto position. Running. The engine is running because that key switch is in the auto position. We can also see running with an ATS transfer. The engine is starting running because the ATS indicated need for the generator power and the key switch is in the auto position. We're going to quickly look at the service page. So this is your first typical page, maintenance status. Each line displays a maintenance item that has been set up via Genlink. The value displayed is approximate percentage of life remaining before maintenance should be performed. So if we click that enter button, it'll take us to plugs, battery, or general. And keep in mind, you can just scroll through. You can look up all of these statuses of your generator. You can predict when maintenance is needed, identify future issues, and keep in mind that this will be in the owner's manual provided to you that you all went over prior to training. Okay, we're talking about systems diagnostics pages. So you'll see inputs come up first, and to get over to this outputs page, you'll just simply push enter like we have navigated in throughout the process. So if you refer to this owner's manual, you'll see the following names are normally assigned to these inputs. So you have key switch in auto, key switch in manual, emergency stop active, remote 2-wire start active. our typical outputs: key switch in auto, activate starter relay, activate fuel relay. So this is kind of where you're programming your wiring with what you would want to be displayed on that H panel. Lastly, I want to go over the exercise portion. So this is a typical internal exercise page. Line 1 is indicating if internal exercise is enabled. This is editable. Line 2 is day of the week, time of the day to start the exercise weekly. That's also editable. And then line 3 is how much time remains before exercise is completed. Typically that's set to 20 minutes. There is a more selection page, but I think we have a good idea of how to navigate through this H panel, how to set the information and display, find the display that we need that's going to work best. Again, use that user's manual, owner's manual provided, and if you have any other questions, feel free to contact me.